Today we'll talk about attribute data, and attribute data is what's contained in the tables or the databases that are behind the vector data or spatial data that makes GIS, geospatial information systems. So there's two main types of tables that we'll deal with in GIS. One are attribute tables, and again, these are connected to the shapefile. And we're talking about vector data here, right? So points, lines, polygons, and each particular element in a shapefile is going to have basically a row in an attribute table. So the most basic thing you could think of is a point for a house that has an address in it, right? Street number, street name, zip code. You can think of like a property tax database. So when was it built? What's the home value, et cetera. Each one of those elements of data is a column, right? Like in a table. And each element, each point would have a row associated with it in the database. We can also have standalone tables, and this would be something like an Excel or CSV file that we import into the GIS. And then we can use database properties or database maneuvers, whatever you want to call them, methods to connect them. So for example, maybe we have property addresses and we want to bring in, we have the points for the property addresses, and then we want to bring in a table that has some sociological data, like census data, right? Typically, you don't have census data at the house level, but you could just imagine there's some data set attributed with the homes. Oh, here's a good one. When I was in undergrad, one of my professors was working on evaluating lead-based paint in homes. And so her research group was working in the city of Durham, where I went to college, to evaluate the risk of a particular house having lead-based paint, which then gets into kids' bloodstreams and has a lot of learning and health outcomes. And so you can imagine they did some research on risk factors based on some basic home information, the year built, the type of structure, right? The type of, is it wood or brick or something like that? And then they could bring that risk information in on a table and connect it to the addresses. And then you'd have a spatial database with lead risk. So that would be a standalone table. You just import it in to GIS, and then you can do some procedures to connect it using, for example, common IDs between the attribute table of your GIS data and information in your standalone table. So here is an attribute table. Does anyone remember how to access this in GIS? Right click on the layer over in the contents pane on the left. Yep. And then there's like a list of 20 things that pops up, but attribute table is in there. Yeah, and it'll open the attribute table on the bottom. Typically, there's going to be an object ID, and this is a unique ID for each element, each point, line, or polygon. There's some information here. It's okay, is it a point, whatever. So that's going to be here. This is kind of like automated stuff. And then here's actual information that's been populated by something else. So if we look at this database, we see we have name, state, county, something, population. I'd imagine that, so we can see this is a US county. So all counties for the US and their polygons, right? So we're storing attributes about each element. The rows are called records. The columns are called fields. Did you have a question?
Yeah. So can you turn on Excel sheet? Excel sheet is kind of right?
Yes. Yeah, and we'll do that. Let's see here. I think you might do that. Did you do that in the yeah, in the lab? Yeah. Yeah. So in the lab, I gave you a table of bridge inventory data. You created a lat and long column, and then you right click on it. So you import the table, right click on it, display XY data, and then you just need to tell it what coordinate system it's in. In that case, it was WGS 84, NAD 83, that was it, right? And then that allowed you to turn it, that table then, it creates a new shapefile. So the table is still there, but it saves a new shapefile, and that table becomes the attribute table for the shapefile. And so that typically only works for point data. You have a row, and each row has a X and a Y. It could be northing, easting, UTM, or state plane. It could be lat long, right? You just have to know what the coordinate system is. And then now that you have that shape file, you can do whatever you want with it, right? Like a normal shape file. So a lot of things we'll be doing is playing with the fields, creating new fields, deleting fields, calculating fields, right? Based on other fields. So you can actually say, okay, I want to know what the population per square mile is, right? And so I could create a new column and say, okay, here's the area of the polygon, and here's the population. I'm just going to divide it by the area, and then I create a new column, right? So just like you would in Excel. So we can join tables, and that's what I'm talking about. When you bring in a table that has other information that's of interest, you can join it to an attribute table. And that might be from some common code. So here's a state code. This is just a system of state codes that we have in the United States. And I could bring in, so here's the table, here's the attribute table. I want to bring in some additional information. I do a join, and we'll talk about how to do joins, but I say join this new table that I brought in with this table based on these common fields, right? These common columns. And then it'll join the table together and just basically append it, right? And so now you have extra fields. Have you all done database work? Like Microsoft Access or anything like that? Yeah, that might come down the road. In engineering, there's a lot of databases out there. I had to do a bunch of database joining and relating and stuff like that for like, you know, stormwater inventory systems, that kind of thing. Anyway, it's a good skill. And so what we're learning is some really basic geodata or database work here, and it can get a lot more complicated. But of course, you can join multiple tables together. Here we can join by state name, and then maybe we have a state abbreviation, and we can join these two tables, right? So you can kind of do this process. So first, I'm going to join these two tables based on the name. This one also has the abbreviations, and I have another table that only has abbreviations, and then I can join it based on that. One-to-one joins are what we kind of are most intuitively would understand, where we take one table and we join it, and for each row in the join table, there's a match in the target table, so one-to-one. We can have many-to-one, in which case we have a smaller table and we have maybe multiple entries here. And so this table then would bring in kind of some state data to this table, which has county data. And then we would bring that information in and kind of match wherever the state's matched. And then there's also one-to-many. This gets a little complicated, and you have to choose which one it's going to pick, because you can't have these multi-dimensional tables, right? So we'd have to say, okay, we're going to bring in, we have many potential matches, and then we have to say, which one are you going to pick first? What's the most important thing? And that could be alphabetical, that could be some other thing. That's probably not something we'll do in this class, but just to know. There's some rules of joining attribute tables, and you'll work on that in the exercises together. But you can say, okay, if there's a match, great. If there's not a match, then delete it, and I don't want to see it. Or if there's not a match, then keep it in there, and you'll just have a bunch of blank fields for that, for the matches. So it's just something to know, and it depends on what you want. If you want to keep all the data, or if you only want to have matches in your latter results.
Update automatically. You. So quickly can
Typically not. So the question was, if you have an Excel file and you're changing data in it, and you link it to a shape file, will it update in the shape file? I think the answer is no. I don't actually know the real answer there, because so if you do a join, meaning you bring a table in, you join it to a shape file, that shapefile's attribute table just got extended, right? You appended that new table to the shapefile. Now it's got all these extra fields, right? If you were to go back and edit the Excel file, will it update what's in the shapefile join? I don't know. I think it kind of just copies it over and then it just sits in there. Yeah. That would be my guess. I would assume that it doesn't automatically update. Did you have a question there?
No.
It's okay. That's okay. You're welcome to do that.
Okay.
Whatever's comfortable, but I might ask you again if I forget. All right. So here's just a summary of cardinality types: one-to-one, one-to-many, and then many-to-one and many-to-many. And it can get a little complicated, but we're probably just going to be sticking with these more simple ones in the analysis we do. So just note that if you don't have a match and you say to keep all the records in the target file when you do a join, that if you don't have a match, then you're just going to end up with some blank fields, right? So Puerto Rico didn't match because we only had a shapefile for the continental US or North American US. And so in this case, we just have some blank information. Here's how to add a join. You right click, do join, and here's the layer that we want to do the join to. Here is the field that we're going to make the join based off of. So this would be a code that would match in the table we're joining to. Here is the standalone table that we brought in. And then here's the field, again, in that standalone table that's going to match. And so this is where things can get kind of tricky and go wrong because, for example, if this district ID was saved as a character originally for some reason with like quotation marks in a CSV file, then you're not going to be able to join it to this if it's an integer, a number. And so the fields have to match. You have to do character to character, integer to integer, decimal point to decimal point. You're probably not going to do matches with decimal points unless it's like decimal degrees or something like that. So you kind of want to be matching codes, that kind of thing, categories. So you might get an error message, and that could come if these field types aren't the same kind of data. Does that make sense? And so you can always check that. You might have to go back and change something in this table and then bring it back in so that it matches the field type. That's something I run into all the time when I'm trying to do joins. So it's pretty straightforward. And then you can check keep all target features. And what do you think this does if I check this? So the target, remember, is the shapefile that I'm joining to. So all it means is I don't want to delete anything from my shapefile. So the shapefile has all 50 states in it. I have this table I'm bringing in. If I don't get a match, I want to keep all 50 states in the shapefile. If I uncheck that, regardless if there's a match or not, if I uncheck that, then maybe there's two things I don't match because of whatever, maybe an error, maybe I just don't have the data, in which case I would end up with 48 things left, right? So that's just depending on what you want to do. We can make charts based on data. That's again, right clicking on the shapefile and you can do charts, and it's basically just for some rough data analysis or visualization. You right click and then just like in Excel, you pick what you want your X and what your Y values are in the fields, and then you can make a plot. So that might be something helpful to do. We can do summary statistics, again, right click, and it'll end up making a new table for you. So if you have this database, you want to do some summary statistics, great. You can also export tables and open them in Excel and do this in Excel. So like these are some tools that are helpful to do in ArcGIS, but maybe better to do in Excel. We'll be creating fields, and we'll do that next week. But going in the attribute table, you can make new fields. You have to tell that, is it a character, a number, an integer, etc. And we can populate that either manually by just entering the information or by doing calculations with other fields, like you would in Excel. Here's a summary of data types. We've talked about this before, but it's good to review. We have short and long. These refer to integers. And here's the range of values. So short can go up to 32,000 plus or minus. Long can go up to billions. Float can have up to 8 significant figures. Double can have much more, so 16 significant figures. Text, alphanumeric, and then we can also have date and time formats. Sometimes it's nice to have actual date and times saved as such. So these ones I always kind of remember: short and long or integer. Text, often you'll have to tell it how many characters to save, and that can be truncated sometimes. And then always just go with double if you're going to have, well, maybe not always. Anyway, just note that double is going to be the biggest user of data. So if you have a shapefile and it's got 10,000 objects in it, and each one has double precision for a bunch of different information in the attribute table, it's going to be a bigger file than if you were to do float, for example. So just keep that in mind. I'll just kind of skip through that. So often, well, always, you'll see a geometry field, shape length, shape area, that kind of thing. And that just is an automatic field that GIS populates, ArcGIS populates. You can also add fields and calculate the geometry. So maybe the shape area is given in some, for example, if your shapefile is projected in WGS 84 lat long, what would area be? What would the units of area be? I don't actually know the answer to that. So it might, I don't know what it would be. And so you can calculate geometry, and we'll do that later, by creating a new field and just saying area km2, kilometers squared, or area mi2. And you can then just say, okay, here it is in Latin long, but let's actually give me something that's meaningful. Or you could just reproject it into UTM or state plane, and then the area would be in square feet or square meters or something like that. So it's just important to know what your units are of the shapefile, because that automatic one, you might not be able to interpret that area very well or length very well. And so specifying what the units are and actually calculating it directly is often important to do. We're probably not going to do this, but it's just good to know that if you are out there collecting data, and you've probably dealt with this if you've ever had a GIS tablet, and you click on, you take a point, you click on it, and there's a drop-down menu. Did you have that for your sidewalk inventory? Like a drop-down menus?
Yeah, they were all pretty much.
Yeah. So what you can do is set it up ahead of time, a shapefile. That might be an empty shapefile, and you say, okay, we're going to have, here's one for trees. So, okay, here's a tree, and here is the type of tree, and I'm going to give it 4 different options: deciduous, coniferous, I don't know, maybe there's nothing else. And so you can specify ahead of time what the options are, so that you always have to enter one of those options, right? And so you won't say, okay, one time I'm going to type in deciduous, another time I'm going to type in deci or decid or something like that. So that keeps everything the same. The category is the same. You could do 1, 2, 3, 4, 5 based on like the health status or height or something like that. So you can set up databases so that you go out, and when you're entering data, it's all prescribed or set what data you can enter, what kind of data you can enter. So here's just some examples. You could imagine What kind of thing is it? A tree, a bench, a light pole? What kind of condition is it? Good, fair, poor. So these would be text, right? Sidewalk, street, power line. What type of land use is it? So I'm going to go out and evaluate land use. And these are things that you pre-program in a domain into a shapefile so that it has to have those categories. I won't get into how to create this. This is kind of a little more advanced than we will be doing in class. Let's just summarize what tables are. Here is an attribute table again. We right-click on a shapefile and go to attribute table. We have records. So these are associated with each element, each polygon, line, or point. We have our fields. Down here, you can kind of see, okay, there's 51 rows, so 51 elements, right? You can select them. You can show everything, or if you click on this, you only show selected. So there's going to be some things where you want to go out and select something and just do a calculation based on what you select. And that's clicking on this little blue triple bar right here, and it'll just show you that. You can right click on any field. You can do sort. You can calculate, delete, summarize. Note that these things down here will actually change the field. So if you do calculate field, you can say, okay, I'm going to do an equation based on other fields. I want to do calculate geometry, something like that. It's going to change everything in this particular field or column. So just be aware of that. If you want to do that, fine. If you want to create a new field and then calculate it, then that might be better. And then you also have some information up here. This is adding a field, deleting a field, calculating a field. All right. A little look at example at calculating fields. Again, you can just right click on any header in the attribute table and it'll bring this dialog up. This is the table, this is the field that you right clicked on. Of course, you can change it with this drop down menu. And then you can basically just do an equation here. So I want to see, in this case, they're calculating the percent Hispanic population, right? So here's the population in 2010. The field name, maybe this is a new field that they made, so Hispanic percent. And I take the population, so I just click on this and it treats it as a variable, right? So these are all the fields that you have in the attribute table. So I double click on this and then it populates it down here. And this is just the notation for bringing a field in to do a calculation on it. So it'll do it for all the rows. So I take the Hispanic population, I divide it by the total population, I multiply by 100, and then I press calculate. And it will update based on all the rows. It's the same as taking an equation in Excel and just dragging it down, right? And it'll do that calculation for you. All right, a couple more things here. First is when we import Excel data. As you know, when you create an Excel file, it comes with sheets. And so by default, Excel will make 3 sheets. They might not all have data in them, right? Usually you just work in the first sheet and that's it. So when you bring an XLS file in or XLSX file, you have to pick which sheet. And so usually it's just going to be sheet 1, and that'll just bring that in as a table. Excel has a lot of formatting and stuff it does to the data behind the scenes. CSV files, you can always open a CSV file in Notepad. Have you guys done that before? And you can actually see what it is, right? So there's no formatting. If it's a character, it'll be probably in quotation marks. If it's a number, it's just a number, right? There's no weird formatting that happens. And so a CSV file is going to be a little easier to bring in because you kind of know what each data type is. So you can always do your formatting in Excel and make sure you have, okay, this is a date, this is a character, this is a decimal, this is an integer. Then save it as a CSV file, open it up in Notepad, make sure it's all the formatting or the data types are what you want, and then bring that CSV file in. That's going to be a little, you're going to probably run into less problems that way. Just putting that out there, especially the dates. Dates are terrible in Excel. I hate dates in Excel. Yeah, it's such a pain. So just kind of know that. CSV files are probably going to be the best bet, but Excel will work. It's no big deal. Yeah, so that's just a brief overview of the tables. Here's some different tables that you can bring in. So CSV files, tab delimited files. So note that ArcGIS cannot read tab delimited files, which has fixed column widths like this. Excel can, so you might have to bring some things into Excel, convert it to a CSV, and then bring it into ArcGIS Pro that way. So there's a lot of different table formats that you'll encounter. In my opinion, CSVs are the best way to go. And you'll note that this CSV file, let's just go back to, yeah, we'll zoom in on this B one right here. The header row is separated by commas. So number, station, and then month. And then you can see the data come below that. So you always have the header as the first row.